Welcome to this audio abstract. First of all, thank you to Rob Pacey for the invitation to discuss this study, Factors Affecting Match Running Performance in Professional Australian Football. Secondly, thank you to the co-authors of this study, Professor Aaron Coutts from the University of Technology in Sydney, and also my colleague from Carlton Football Club, Joel Hocking and Tom Kempton. So really briefly, the basis for this study was established by previous research in Australian football and rugby league that identified a range of match-related and individual characteristics that influence running output during matches. These include player calibre, player fitness, number of rotations, as well as match outcome, match location, and recovery between matches. So this research suggested to us that there is a likely interplay of factors that influence running output during competition matches. And by identifying and quantifying the effect of these factors, we can better contextualise and interpret match running data typically collected during AFL games. We use multi-level mixed modelling for our analyses, and the reasons for this were twofold. Firstly, we wanted to examine the individual influence of factors that we chose for our analysis, whilst accounting for the influence of all other factors. Secondly, we wanted to account for pseudo-replication of data, and this is where the true correlations between variables are clouded or masked by the inherent relationships between data collected from the same individual across multiple time points. And this is quite a common occurrence in observational research of team sport athletes, where we collect data from the same cohort of players across one or two competition seasons. So data were collected from 34 professional Australian footballers from the one club during the one season across 15 matches. We used GPS microtechnology to collect total distance and high-speed running data during those matches. High-speed running was considered any distance covered at a speed of 20 kilometres per hour or above. We also used a player fitness score, which was derived from a 2-kilometre trial conducted during the pre-season as a measure of maximal running speed. As you can see here, the other covariates we used were travel, recovery length, season phase, strength of opposition, match result, number of stoppages, and number of rotations. To quantify the effect of these factors on relative total and high-speed running distance, we calculated effect sizes, as you can see here. We used relative total and high-speed running distances as opposed to absolute values to provide a better indicator of player running output during games by accounting for the time they spent on the interchange bench. So to the results. Matches won, more player rotations, and matches against stronger opposition all resulted in increases in relative total distance, while early season phase, more stoppages and away matches resulted in reductions in relative total distance. Away matches and matches lost result in small reductions in relative high-speed running, while number of rotations also had a positive effect on relative high-speed running. Player fitness had a large positive effect on both relative total and high-speed running distances also. So these findings certainly confirmed our initial theory that there is an interplay of factors responsible for the variation in running output during AFL matches. The primary applications of these results are that certainly context is required when interpreting running output from games. Over recent times, GPS data has been somewhat popularised as a measure of individual performance during games, based on the fact that the further a player runs, the better they have performed. However, previous research certainly has refuted this, and our results emphasise the need to contextualise running output, particularly when using it as a performance measure. Unsurprisingly, players with a greater maximal running speed perform more relative high-speed running and total distance during matches, but it should be noted that these players with greater aerobic capacity or maximal running speed are often placed in positions where greater relative running output is required, such as midfield positions. A surprising finding from our study was that early season phase was associated with reductions in relative running output, This may suggest the need to increase the volume of match-specific conditioning conducted during the pre-season period, particularly leading into the competition season. Certainly there are a couple of limitations that should be considered when interpreting our findings or applying our findings. Running output may have been reflective of the individual characteristics and coaching philosophies and team tactics of the observational group, given that we only examined data from one season. Certainly 15 matches is a small sample size. Our results could potentially be strengthened by a combination of multiple cohorts across multiple seasons as well. Lastly, a 2 kilometre time trial that we use for our player fitness assessment is potentially not the most appropriate or the most specific running test for Australian footballers. A yo-yo intermittent running test may have yielded different results to the ones we found in this study. So that's a really brief summary of this study. You can find the full text of this paper on my ResearchGate page. Just search Samuel Ryan. Otherwise, you can find me on Twitter at Sam_Ryan1, and I can certainly get you a copy of the text. Thank you for listening.